Hello, I am IPSITA GHOSH. I am the Assistant Professor of Swami Vivekananda Institute of Science and Technology. And today I am going to discuss on the topic of classifications of signal. So, now, what is signal? A signal is formally defined as a function of one or more variable which conveys some information from one point to the other point. Here some examples are shown: radio or television signal, telecommunications and computer signal, biomedical engineering signal. So it may be a function of time, temperature, position, pressure. In the electrical sense, the signal can be voltage or current, and it is a function of time as an independent variable. In the daily life, we come across several electrical signals such as radio signal, TV signal, and many signal we come across are naturally generated signal, and few signals are also generated synthetically. So they are the classifications of signal. The first one is continuous time signal and discrete time signal, analog signals and digital signals, deterministic signal and random signal, periodic signal and non-periodic signal, even signal and odd signals, energy signals and power signal. First, I am discussing about continuous time signal. So, continuous time signal may be defined as mathematical continuous function. This function is defined continuously in the time domain. For continuous time signals, the independent variable is time t, and it is represented by like following figure. Suppose it is a figure of xt where it is dependent on the time scale. Thus, we can say that signal of continuous amplitude and time is known as a continuous signal, and the signal will have some value at every instant of time. So, amplitude or value varies continuously with time. In the electrical signals derived in proportion with the physical quantities such as temperature, pressure, sound, etc. are generally a continuous signal. And some other examples of continuous signals are sine wave, as I am showing in the figure, sine wave, cosine wave, triangular wave, and the continuous time signal are represented by xt, where x represent the shape of the signals and t shows that the variable is time. Next, discrete time signal. It is defined only at discrete time instant. So a discrete time signal is defined only at certain time instant. For discrete time signal, the amplitude between two time instant is just not defined. For discrete time signal, the independent variable is time n. A discrete time signal is represented by xn. This means that to represent a discrete time signal, we shall enclose a independent variable n. We can say that if the signal is represented only at discrete instant of time, then it is known as discrete time signal. So it is often derived from continuous time signal by sampling it at uniform rate. Suppose if we take the blood pressure reading of a patient after every 1 hour and plot the graph, then the resultant signal will be taken as a discrete time signal. Next type is analog signal and digital signal. In case of analog signal, the signal whose amplitude can take on any value. Amplitude can take on any value in the continuous range. In the continuous time signal, I am telling that at any time instant they have a value, and that may be finite or infinite. But in case of analog signal, it is completely depend on the amplitude scale. It is completely depend on the amplitude scale. At every instant of time or at any instant of time, they have an amplitude. They has an amplitude which is in the finite range or infinite range. In case of digital signal, a signal whose amplitude can take on only a finite number of value. That means the analog signal and digital signal is completely based on the amplitude axis. In the analog signal case, the amplitude can take any value. In the digital signal case, the amplitude take finite number of values. But in case of continuous time and discrete time signal, it is limited on the time scale, not in the amplitude scale. In the amplitude scale, it can take any value, but in the time scale, in the continuous time scale, they take any value of t. That in the discrete time scale, they take finite value of t. That means continuous time and discrete time signal is based on the time scale, and analog signal and digital signal are based on the amplitude scale. So in the figure analog signal, here I am showing sine wave because it take any value in the amplitude scale, and in the digital signal I am showing the square wave because it is from certain value to another certain value. Okay, next classification is deterministic signal and random signal. Deterministic signals are those signals which can be completely specified in time. That means the pattern of this type of signals is regular and can be characterized mathematically. Also, the nature and the amplitude of such a signal at any time can be predicted. Suppose I am taking this one signal like sine wave. I am taking the signal of sine wave. So in case of sine wave, I am knowing the nature of the sine wave. It is started from zero value and going to the peak value, then again comes to the zero value, and then again going to the negative value. So in that case, I am predicted the nature of the signal. And in case of cosine wave also, that means the all signal that I am knowing, like ramp signal, a square signal, in that case they are all deterministic signals. So there is no uncertainty with respect to its value at any time. But in case of random signal, or it is also said that non-deterministic signal is one whose occurrence is always random in nature. The pattern of such a signal is quite irregular to us. Non-deterministic signals are also called random signal. Suppose the example of non-deterministic signal is noise generated in the electrical circuit. Such a noise signal has probabilistic behavior because we don't know how they comes to us. So they are called random signal. Next one is periodic signal and non-periodic signal. A signal which repeats itself after a fixed time period is called a periodic signal. The periodicity of the signal can be defined by mathematically. Suppose xt equal to xt plus t naught. That is the condition of periodicity. That means xt repeats itself after t naught time or after t0 second, where t0 is called the period of signal xt. In other words, signal xt repeats itself after period of t0 second. Some example of periodic signals are sine wave, cosine wave, square wave, etc. In the figure also, here I am showing some the nature of the signal is repeated after t0 time later. A non-periodic signal, a signal which does not repeat itself after a fixed time period or does not repeat at all, is called as a non-periodic or a periodic signal. The non-periodic signal do not satisfy the condition of periodicity. Sometimes it is said that an aperiodic signal has a period t0 equal to infinity. That means after infinity time later, they repeats itself. After infinity time later, they repeats itself. Like a decaying exponential signal is a non-periodic signal because it repeats itself after infinite time later, because it does not repeat itself basically. So a signal which does not repeat itself after a fixed time period or does not repeat itself at all, in that case exponential signal is a non-periodic signal. Next one is even signal and odd signal. In case of even signal, I am showing x minus t equal to xt. X minus t equal to xt. That means in the negative scale also and in the positive scale also it is same. It is also said that it is a symmetrical signal. It is said that it is also symmetrical signal. A signal xt is said to be symmetrical or even if it satisfies this condition. That is the condition for symmetry. Xt equal to x minus t, where xt equal to value of signal for positive t and x minus t equal to value of the signal for negative t. So in the figure FET, E means even signal. In the positive side, the nature of the signal or the shape of the signal or the figure of the signal is same as in the negative side. But in case of odd signal or anti-symmetric signal, the signal xt is said to be antisymmetrical or odd if it satisfies the condition for antisymmetry. Now, what is the condition for antisymmetry? This is x of minus t is equal to minus of xt. So, in the figure, the positive sided function by positive sided signal is shown in figure, and in the negative side it is opposite to the amplitude scale. So in the amplitude side, here I am giving a negative sign. X of minus t is equal to minus of xt. That means the xt has an amplitude, and in the x of minus t range, the xt has the same amplitude but in the negative scale. So it is a odd signal. So I am giving the example as the symmetrical signal is a cosine wave and the odd signal as a sine wave. Next one is energy signal and power signal. In case of energy signal, a signal with finite energy is called energy signal. Finite energy means they have energy from zero value to the range of finite. That means less than the infinite value. And the energy is obtained by the following equation: E equal to minus infinity to plus infinity mod of xt whole square dt. The signal energy does not indicate that the actual energy of the signal, because the signal energy depends not only on the signal but also the other factor. So in that case, the signal energy is dependent on the amplitude of xt. Suppose I am taking one resistor circuit. If a voltage xt is applied across a resistor's R ohm, then the current through the resistor is xt divided by R, because xt is the voltage and we know I equal to V by R. And in that case, suppose I am taking the power, that is P, which is equal to I into V, and if we put the value of I in that case, then I have Pt equal to x square t divided by R. And if we substitute the value of R equal to 1, then we get x square t only. So energy dissipated is given by minus infinity to plus infinity mod of x square t mod of xt whole square dt. So if R equal to 1, then the energy dissipated in the resistor is denoted by the value E, and the signal energy E may be interpreted as the energy dissipated in a unit resistor if a voltage xt is applied across this unit resistor. So for real signal, energy is E equal to integration minus infinity to plus infinity mod of xt whole square dt. This is also for a complex valued signal. That's why I am giving the mod value. Similarly, the energy in a discrete time signal xn is also given as E equal to summation over n equal to minus infinity to plus infinity mod xn whole square. Signal energy must be finite for it to be meaningful. For energy to be finite, the signal amplitude xt or xn must go to 0 as we go from 0 to infinity range. Now I am going to the power signal. A signal with finite and non-zero power is an power signal. So that means they have a finite and non-zero power. So the power is denoted by actually average power. So average power P is equal to limit t tends to infinity 1 by t. T is the whole time period. Integration from minus t by 2 to plus t by 2. That means I am taking the one time period only, mod xt whole square dt. So we define average power, which is time average of the signal. That's why I am giving 1 by t, and I am taking only one time period. So this is the expression for power signal. Thank you.